Good morning. In this session, I want to explain JEE Main 2025 Phase 2 April 4th morning shift question paper, particularly physics. If you observe all the physics question papers given in JEE Main 2025, relatively physics papers are easier compared to mathematics and chemistry. They are not lengthy, they are not difficult. But only thing is concept based, application oriented. So here, while answering these question papers, the strategy is very simple. Absolute concentration, confidence without any distraction and positive attitude. The thumb rule is if you can answer all the questions you know in that particular question paper, for sure you are going to get a very good percentile. In all these question papers, 20 out of 25 questions, 20 questions are easy to moderate level. So you can answer them confidently if you prepare well. So that conceptual learning along with application is very important, and time management is the ultimate thing needed in the examination. So you have to concentrate very deeply during those 3 hours. So I'll start explaining this question paper, physics question paper given in JEE. Look here, read the first question, that is question number 26 onwards are physics questions. So first question, it is given like this. 26th question. Look here, a light wave propagating with plane wavefront of type x plus y plus z is constant. The angle made by the direction of propagation with x-axis. This we can very easily pick up the answer based on the concept of direction cosines. Alpha is the angle made by the given vector with x-axis. Then cos alpha is given by ax by modulus of a if a bar is equal to ax I bar plus ay j bar plus az k bar. That concept we know from vectors. So here in this expression, if you apply the same concept here, cos alpha is equal to coefficient of x is ax, that is 1 root of their coefficients, 1 square plus coefficient of y is 1, coefficient of z is 1. So this is 1 by root 3, which implies alpha is equal to cos inverse 1 by root 3. That is the angle made by that given vector with x-axis. Okay. Now coming to the next question, look here. The equation for a real gas is given as P plus A by V square into V minus B is equal to RT. Here P is the pressure, V is the volume, T is the temperature, R is the gas constant. A, B are just constants. We do not know anything about them. So here in this question, what is asked? See, if P pressure, volume, temperature, gas constant respectively, dimensions of A, B to the power of minus 2 are equivalent to one of the given 4 options. So our primary objective is we want to find the dimensional formula for A, B to the power of minus 2. So, or this is equal to A by B square. So, to find the dimensional formula for A and B, let us use the principle of homogeneity. So, A by V square is added to P here. So, P and A by V square should have the same dimensional formula. So, dimensional formula for P is m L to the power of minus 1 T to the power of minus 2. A we do not know, we need to find it out. And volume. Volume dimensional formula is L cube, here V square. So, L to the power of 6. This implies dimensional formula for A is m L to the power of minus 1 into L power 6 is L to the power of 5 T to the power of minus 2. And coming to the dimensional formula for B, it is same as that of volume. Again, from principle of homogeneity, as B is subtracted from V, its dimensional formula must exactly be the same as dimensional formula for volume. So, dimensional formula for B is same as that of volume, that is L cube. Now, we want to find out A by B square. For A, look here, m L to the power of 5 t to the power of minus 2, right, by B square, that is L cube whole square, L to the power of 6. If this goes to the numerator, it becomes m L power minus 1 t to the power of minus 2. This is the dimensional formula for A by B square. So, we have to check out the given physical quantities with the same dimensional formula. So, if you read the options carefully, here energy density. Let us see, energy density is the fourth option given. So, energy density is energy per unit volume. Energy per unit volume implies energy dimensional formula is ml square t power minus 2, volume is L cube. So, if you take that to the numerator, it becomes m L to the power of minus 1 t to the power of minus 2, which is exactly same as that of A by B square. Hence, we can say A by B square dimensional formula is equivalent to the energy density, that is option number 4 given in the question. Okay, now let us go to 28th question. Okay, so look into question number 28. See here, a cord of negligible mass is wound around a rim of a wheel supported by spokes. By a rim supported by spokes means that is considered as a ring. That is the most important idea of the problem. Rim supported by spokes means while considering the moment of inertia about its natural axis, we consider it as a ring. It is not a disc, right? Now, here the diagram given is like this. This is a ring on which a cord is wound around, and this is being pulled by a force F. In the problem, mass of the wheel is given as 10 kg. Radius of the wheel is given as 10 centimeters. Immediately you need to convert that into meters, 0.1 meters, and it can freely rotate without any friction. Initially, the wheel is at rest. So, the initial angular velocity of the wheel is 0. Find its angular velocity after the cord is unwounded by 1 meter. By applying continuous force, naturally, the wheel rotates and the cord gets unwounded. By the time the cord gets unwounded by 1 meter, you need to find out the angular velocity of the wheel. So, the problem looks like a bit bigger. So, in that case, we go to the end of the problem. Here, what is asked? You are supposed to find out angular velocity. From equations of motion in non-uniform circular or rotatory motion, omega 2 square minus omega 1 square is 2 alpha theta. In this particular problem, initial angular velocity is 0. Omega 2 square is equal to 2 alpha theta, implies omega 2 is equal to square root of 2 alpha theta. Okay. So, you are asked to find out omega 2. What is the final angular velocity? So, to find the angular velocity, we need to find out alpha and also theta. Look here. See, RF, the torque, this is equal to I alpha. In this particular case, RF is equal to, as that is a ring, moment of inertia is mr square alpha. from that alpha is equal to R and R gets cancelled, F by M R implies alpha is equal to, force is given as 20 Newton. This is in this diagram, it is given as 20 Newton. So 20. Mass is given as 10 kg. So this is 10. And R is given as 0.1. This is 0.1. 10 into 0.1 is 1. So alpha is equal to 20 radian per second square. So alpha is found. What else is needed? Theta. We know r theta is equal to linear displacement. Theta is equal to 1 by, radius is given as 0.1. So theta is equal to 10 radian. So theta is also known. From this formula, omega 2 is equal to square root of 2 alpha theta. So that is 20 into 20 under root. It is 20 radian per second. That is the angular velocity of the wheel by the time the cord is unwound by 1 meter. Right? That is 28th problem. Now let us go to 29th problem. Look here. A slanted object is placed on one side of a convex lens. So I am talking about question number 29. The diagram given is like this. This is a convex lens. Focal length of the convex lens in the question is given as 20 centimeters, and the slanted object is placed at an angle alpha. And here in the problem it is mentioned that, see here it is mentioned like this. This side is given as 1 centimeter, this side is given as 2 centimeters. Angle made by the slanted object with the principal axis is given as alpha, and the object distance is given as 30 centimeters. Here the question asked is angle made by the image with the principal axis. So we have to find out the angle made by the image. See here, first we must have clarity of the problem. Focal length is 20 centimeters, object distance is 30 centimeters. So the object is placed between F and 2F. So a real inverted magnified image will be formed on the other side of the convex lens. So let us imagine this as the position of the image distance. So the image will be like this. This is the new angle made by the image with the principal axis. So here from this diagram again, going to the end of the question, tan alpha dash is equal to, opposite side is new height, and this is equal to d into v, where dv is the shift in the image locations. See here, you need to find out alpha dash here. So from this diagram, tan alpha dash is equal to h dash by dv. And we know from the equation m is equal to v by u, we can say du is equal to m square times d du. dv is equal to m square times, where m is the magnification. And another thing is size of the image, that is h dash is equal to, vertical height is linear magnification times the initial height. This concept is the most important thing. Actually, we have done problems of that kind in case of slanted objects placed in front of a convex lens. So here dv is equal to m square du h dash. So first of all, if you want to get these values, the most important thing is m, and magnification m is equal to v by u. So we need to find out V here. So from the equation 1 by F is minus 1 by U plus 1 by V. 1 by F is 1 by 20. U, as the distance is taken as negative, minus of minus, it becomes plus 1 by 30 plus 1 by V, from which 1 by V is equal to 1 by 20 minus 1 by 30. That is equal to 60. 3 minus 1, 3 minus 2. So V implies V is equal to 60 centimeters, whereas U is equal to 30 centimeters. From this, magnification is V by U. So magnification is equal to 2. Is that clear? Then the problem is done. Now follow me very carefully. We want to find out dV. So dV is equal to m square. M square is 4 times the horizontal distance. This is 1. Okay, so this is 4. And h dash is equal to m, that is 2, into vertical distance, that is equal to 2. So dV h, that implies this is also equal to 4. So magnification, this is tan alpha dash is equal to h dash is equal to 4 and dV is equal to 4. This is equal to 1, which says that alpha dash is equal to 45 degrees. Look into the options. You have plus 45 degrees, minus 45 degrees. Simply that magnification or whatever, that is, as this is inverted image, we say it is negative. So alpha dash is equal to minus 45 degrees is the right choice for that problem. So in the options given, second option is the perfect option for that problem. Okay, so here, so actually in this problem, we know in case of slanted objects placed in front of a convex lens, vertical height gets magnified, it becomes m times the initial vertical distance, and horizontal distance becomes m square, aerial magnification, m square times the initial horizontal distance. That is the main concept involved in that problem. Now look into question number 30. Look here, consider two infinitely plane conducting sheets of surface charge density plus sigma minus 2 sigma. You are asked to find out the net force acting on the charge Q placed halfway between them. See here, just there are two infinite sheets of charge of charge densities. This is plus sigma and this is minus 2 sigma. And P is the midpoint because it is at a distance d by 2 from this sheet, d by 2 from this sheet. So P is the midpoint. And here, even if it is not a midpoint, doesn't matter, because electric field intensity due to a charged sheet at any point is given by sigma by 2 epsilon naught, which is independent of the distance. So anyway, here the question asked is, what is the force on the charge placed at this point? So force on a charge Q placed in a field of intensity E is QE. So to find the force on the charge, we need to find out the electric field intensity at that point. So electric field intensity at this, due to this positive charge is away, due to this negative charge is towards. So both electric fields are in the same direction. So the net electric field intensity at that point is E1 plus E2. Due to this, it is sigma by 2 epsilon naught, as its charge density is sigma. Here the charge density is given as 2 sigma, it becomes 2 sigma by 2 epsilon naught. So 2 plus 1, it is 3 sigma by 2 epsilon naught is the electric field intensity at that point. So force on that charge becomes QE So 3 sigma by 2 epsilon naught into Q. This is the answer for the force experienced by a charge placed at the point P in between two dissimilarly charged sheets. Okay. Now, let us move on to the next problem. Riverboat problem. Look here. Look into this 31st question. A river is flowing from west to east in this direction with a velocity 9 km/h. Just I am writing down the data given. A boat is capable of moving at a maximum speed of 27 km/h. That is the maximum speed, possible speed for the boat in still water. It crosses the river in half a minute. Time taken by the river, by the boat to cross the river is half minute. While moving with maximum speed at angle 150 degrees, then what is the width of the river? Now, whatever is given, I am trying to draw it in the form of a diagram. See here, river is flowing in this direction, west to east. So, this is the direction of water flow. Boat is rowed at an angle 150 degrees with the flow of water, right? And here, so this angle becomes 150 minus 90, 60 degrees. Component of boat velocity in this direction becomes VB cos theta. Width of the river is SA. Then time taken to cross the river will be S by VB cos theta. In this problem, water velocity is redundant. We don't need that at all. So, here T is given, VB is given, theta is given. You need to find out the width of the river. But you have to be very careful. Boat velocity is given in kilometers per hour. Time is given in minutes. So, you have to convert that into one system. Look at the options. In the options, distance is given in meters. So, let us convert velocity into meter per second, time also into seconds. So, VB is equal to 27 km/h, 27 into 5 by 18, this is 15 by 2 or 7.5 meter per second. Time is half minute, that is 30 seconds. Now, substituting these values in this expression, T is equal to 30, yes, we do not know, and VB is 7.5 into cos theta is 60. So, 30 is equal to S by 7.5 by 2. So, implies S is equal to 30 into 7.5 into half. So, it is 15 into 7.5. So, 15 into 7.5 is 112.5 meters. So, the width of the river given here is 112.5 meters. Okay? So, it is a straight question. T is equal to S by VB cos theta from that diagram. Now, let us go to the next problem. See here, question number 32. A point charge plus Q is placed at the origin. A second charge plus 9Q is placed at D 0, 0. See, let us take this as x-axis. So, at the origin, a charge plus Q is placed. At a point D 0, 0, y coordinate is 0, z coordinate is 0, that simply says that point is on x-axis again. Again, at the point D, 0, 0, plus 9Q charge is placed. the point in between where electric field intensity vanishes. The point where electric field intensity is 0 is called null point. So, distance of the, if you take this as Q1, this as Q2, we know pretty much well, distance of the null point is x is equal to d by square root of Q2 by Q1 plus 1 if the two charges are similar and the null point lies in between them. Actually, from where we got this derivation is due to this electric field intensity is in this direction, due to this in this direction. So, Q1 by x square is equal to Q2 by d minus x whole square. On solving that, you will be getting x as like that. So, here it is d by square root of Q2 is 9Q by Q plus 1. So, it is d by root 9 is 3, 3 plus 1 is 4, d by 4. So, it is on x-axis. The coordinates of the point where electric field intensity vanishes in Cartesian coordinate system becomes d by 4 comma 0 comma 0. That is the answer, right? Now, let us move on to the next problem. See how easy the problems are. 33, question number 33. The battery of a mobile phone is rated as 4.2 volts. That is the maximum possible voltage applicable to the battery. And the current rating is 5,000. This is the voltage rating and the current rating is 5,800. There is a spelling mistake. That is amperes. Okay. How much energy is stored in it when fully charged? So, here when fully charged, energy stored expression is just VI. That is 4.2 into 5,800. So, that is 20. Actually, see 6 4s are 24. It comes around 24. So, 24.4 kilojoules. Actually, you will be getting like this 24,360 approximately on multiplication. So, here if you want to convert that joules to kilojoules, you have to multiply that with 10 power minus 3, 24.36, which is approximated as 24.4 kilojoules is the answer. It is such a simple question. Maximum energy stored is, if voltage current ratings are V and I, U is equal to V into I, right? Now, let us go to the next problem, that is 34th problem. Look here, a particle is subjected to two simple harmonic motions. See, x1 is equal to root 7 sine 5t and x2 is equal to 2 root 7 sine 5t plus pi by 3, right? Where x is the displacement, t is the time. Maximum acceleration, the value of x is. Here, x is these two. A particle is subjected to two simple harmonic motions. That is, x is due to the superposition of these two simple harmonic motions. Then, see here, we take this as amplitude of the first oscillation, this as the second oscillation. From the relation a sin omega t, here omega is 5 and the phase difference between them is, this is sin phi t, this is sin phi t plus pi by 3. So, the phase difference between them is pi by 3. So, amplitude of the first wave is root 7, amplitude of the second wave is given as 2 root 7. So, when those two waves are superposed, then the amplitude of the resultant wave formula is root of a1 square plus a2 square plus 2a1 a2 cos phi. So, here root 7, 2 root 7 this is. So here you can take that, okay, anyway, this is A1 square plus A2 square, 4 into 7 plus 2, A1 is root 7, A2 is 2 root 7, and cos phi is 60 degrees, that is 1 by 2. So 2 and 2 gets cancelled, root 7 into 7 is 7. So if you take that 7 as a common factor outside, it will be like this, 1 plus 4 plus 2. This is a root 7 implies amplitude is equal to 7. Okay, so what is asked in the problem? You need to find out the acceleration of the particle. What is the formula for acceleration? See here. So, what is the formula for acceleration? Acceleration is, maximum possible acceleration is omega square a. Omega is, from this expression, what is omega? See here, omega is 5. So, omega square is 5 square and amplitude is 7. So, this is 25 into 7. So, this is 125. 125. Look here. Here it is given in centimeters. These x and y values are given in centimeters. So, this amplitude will be in centimeters. If you convert that into meters, it will be 125 into 10 power minus 2. It is a numerical question asked like this. Its acceleration is x into 10 power minus 2. Find out the value of x. So, acceleration is 125 into 10 power minus 2. So, x is equal to 125. That is the numerical question given in the problem. Clear? Okay. Let us go to the next problem. This is from magnetism. Relation between magnetic susceptibility, Xi, and the magnetic permeability. Okay, so here we know mu r is equal to 1 plus Xi. We have derived this equation actually in our regular classes. So here, if you look at the options, mu r is not given. So mu r is equal to mu by mu naught. So mu by mu naught is equal to 1 plus Xi. If you look at the options, Xi is asked here. So Xi is equal to, if you take this to the other side, mu by mu naught, if you take that one to the other side, it is mu by mu naught minus 1. So first option given is correct. Xi is equal to mu by mu naught minus 1. Such a simple question. Actually, we know this, isn't it? So from this, mu r is equal to mu by mu naught is equal to 1 plus Xi. Xi is equal to, if you take that one to the other side, mu by mu naught minus 1. So first option is true for that question. Okay. Now let us go to question number 36. A Zener diode with 5 volts Zener voltage is used to regulate an unregulated DC voltage input of 25 volts. For a 400 ohm resistor connected in series, Zener current is found to be 4 times the load current. What is the load current? What is the load resistance? See here, there is only one model in all examinations based on Zener diode as voltage regulator. So here, this is the DC source connected, this is the series resistance connected, and this is the Zener which is under reverse biased condition, and this is the load resistance. That is the diagram of Zener diode as an voltage stabilizer. In this particular case, the input voltage is given as 25 volts and Zener voltage given as 5 volts. This, if we use 5 volt Zener diode, it's understood the regulated power supply or output across the load resistance will be 5 volts, right? Now, look here very carefully. From Kirchhoff's law, observing this mesh, 25 is equal to voltage across this resistance plus Zener voltage. So, 20 plus 5 must be equal to 25. And that resistance is given as 400 ohms. Let us try to find out this current. I is equal to voltage by resistance, 400, right? If you want to express current in milliamperes, so multiply that with 10 power 3, or it doesn't matter, leave it like that. See here, 20 by 400, this is 1 by 20. 1 by 20 amperes. If you want to convert that into milliamperes, 1 ampere is 1000 milliamperes. So, it is 1000 by 20, that is 50. So, 50 milliamperes. This is the most important part of the problem, the total current. Now, current through the load resistance is IL. Zener current is found to be 4 times the current through the load resistance. From Kirchhoff's law, I is equal to, I is entering this junction. So, I is equal to IL plus 4IL. So, I is equal to 5IL. So, I is 50. That is equal to 5 into IL. That implies IL, load current, is equal to 50 by 5, it is 10 milliamperes. So, the current through the load resistance here is 10 milliamperes. Okay? Current through the load resistance is 10 milliamperes. And the next part of the question asked is load current and load resistance is also asked. So, here options are given here. Load current and load resistance. See, voltage is given, current is given. From Ohm's law, V is equal to IR, R is equal to V by I, 5 by 10 milliamperes. So, this is 5000 by 10, or resistance is equal to 500 ohms. That is the load resistance. So, load current is 10 milliamperes, load resistance is 500 ohms. So, fourth option given is the correct answer. Okay. Now, going to question number 37. Look into that question number 37. In adiabatic process, which of the following statements is true? Adiabatic process means heat energy supplied to the system is 0. So, heat supplied is 0. So, dQ is equal to 0. That we know for an adiabatic process. Molar heat capacity is 0. First option is molar heat capacity is infinite. Molar heat capacity is, in general, heat capacity is Ms, that is equal to delta Q by delta theta. That is the molar heat capacity. Heat supplied to the system per 1 degree centigrade rise of temperature is called molar heat capacity or heat capacity. This is delta Q by delta theta. Ms or molar heat capacity is delta Q by delta theta or dQ by d theta. Here, if dQ is 0, molar heat capacity is 0. So, first option, molar heat capacity is given as infinity. Second option, work done is equal to the increase in internal energy. Actually, if you go to the first law of thermodynamics, dq is equal to du plus dw. As dq is 0, dw is equal to minus du. That means work done is equal to du is positive. If du is positive, increase in internal energy. Here du is negative, work done is equal to decrease in the internal energy. But in the second option, work done by the gas is equal to increase in the internal energy. It is wrong. And look at the third option. Molar heat capacity is 0. That is perfect because dq is 0, molar heat capacity. Heat supplied to the system is 0. So, molar heat capacity of the system also becomes equal to 0. So, third option is true for the 37th question. Now, let us move on to question number 38. See here, question number 38. A square lamina OABC of length 10 centimeters. So, I am redrawing that. This is a square lamina of side 10 centimeters. Number of forces, it is pivoted at this point O, meaning it cannot be set into translatory motion, it can be set into only rotatory motion about this point as the axis of rotation. Now, here number of forces are applied like this. Along this 10 Newton, 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 along this, what is the force applied? See here, if you really look at the problem, you can directly say by gut feeling or whatever, you can say the answer is 10. But you are not supposed to tell the answer like that. You have to work it out. Now, look here. The torque produced by this force about this point, force is applied along the horizontal, vertical distance between them or perpendicular distance is 0. Hence, torque due to this force becomes equal to 0. And this creates a torque in this direction. Let us call it as tau1. And this creates a torque in this direction. This creates an equal and opposite torque because this is 10 into this distance. This is 10 into this horizontal distance. As that is a square lamina, as the distances are equal, these two torques, one is clockwise, other is anti-clockwise, they just cancel one another. So, we are left with this again. See, torque due to this force is 0 because this force is acting along the vertical. Horizontal distance of this force with respect to the origin is 0. Torque due to this is 0. Now, this produces a torque in this direction. So, if you look at the diagram, tau1 and tau2 are the only two torques acting on that. Okay. So, tau1 is clockwise, tau2 is anti-clockwise. That square plate remains stationary if the net torque is equal to 0. So, definitely torque due to this force, this perpendicular distance is 10 centimeters, need not convert that into meters because on both sides it is in centimeters, they get cancelled. Okay, 10 into F, this is equal to, this distance is also 10 into F is 10 Newton, this and this gets cancelled. So, the force applied at that point is 10 Newton. Okay, so usually suppose when I looked at the problem, answer is straight, it is 10 Newton. But when you are writing in the exam, sometimes we may err in directly picking out the answer. So, let us slowly think about the torques and all those things. We have to finally say that net torque is equal to 0. So, we have to equate clockwise torques. Sum of the clockwise moments is equal to sum of the anti-clockwise moments. That's it. Okay. Now, let us go to the next problem. B1 be the magnitude of the field at the center of a circular ring. At the center of a circular ring, intensity of magnetic induction field is mu naught Ni by 2R. Let us call this as B naught. Okay, so this is a ring. Let this be the axis of the ring. This is a point P at a distance x, which is equal to n times r. So at that point, actually B is equal to mu naught Ni r square by r square plus x square whole to the power of 3 by 2. From that, we proved that B is equal to B naught by 1 plus n square to the power of 3 by 2. So, look here very carefully. From this, n is equal to x by r. Here it is given that B2 be the magnitude of the magnetic field at an actual distance x, such that x is to r is equal to 3 is to 4. That means x by r is equal to 3 by 4. That means x is equal to 3 by 4 times r. Comparing this with that, x is equal to nr, n value is 3 by 4. So what is asked in the problem? You have to follow this very carefully. The intensity of magnetic field at the center is taken as B1. Intensity of magnetic field at a distance x on its axis is taken as B2. So B2 is equal to B1. This formula we know. B2 is equal to B1 by 1 plus n square to the power of 3 by 2. You are supposed to find out B2 by B1. So from this expression, B2 by B1 is equal to 1 by 1 plus n square to the power of 3 by 2. See, actually if you are thorough with the notes and synopsis, we can directly arrive at that equation. B is equal to B naught by 1 plus n square to the power of 3 by 2. All of us know pretty much well. So from that expression, it is so simple now. Look here. It is B2 by B1 is equal to 1 by 1 plus n is 3 by 4. 3 by 4 whole square, 9 by 16 times whole to the power of 3 by 2. So need to do the calculation part carefully. Look here. This is equal to 1 by, if you take LCM as 16, 16 plus 9 to the power of 3 by 2. So this is equal to 1 by 25 by 16 to the power of 3 by 2. Taking square root, it becomes 5 by 4 to the power of 3. Or 4 goes to the numerator, 4 cube. 4 4s are 16, 4s are 64 by 5 cube is 125. So B2 by B1 is equal to 64 by 125. That is the answer. 64 by 125. So here the only concept is at the center, intensity of magnetic induction field is B naught. At a distance x from the center of a circular coil, intensity of magnetic induction field is B. If x is equal to n times the radius of the coil, B is equal to B naught by 1 plus n square to the power of 3 whole to the power of 3 by 2. Okay. So from that is the answer we get. Right. Let us go to the next problem. Considering Bohr atom model for hydrogen atom, energy of hydrogen atom in ground state is same as that of. So, in all the options, energy of hydrogen atom in the ground state. We know energy of hydrogen atom in its ground state is minus 13.6 electron volts. In any hydrogen like atoms, energy is given by minus 13.6. Energy is given by minus 13.6 Z square by N square. Okay, so that is the energy of any hydrogen-like atom with atomic number Z, and N is the number of the orbit in which the electron is revolving around the nucleus. Now, in the first option, it is given energy of hydrogen atom in ground state is same as that of helium ion in the first excited state. For helium, atomic number is 2. First excited state, N is equal to 2. So, again implies Z square by N square is equal to 1. Hence, its energy is also equal to minus 13.6. So, this is right. Energy of hydrogen atom in its ground state is equal to the energy of helium ion in the first excited state. If in the first excited state, the electron jumps from first orbit to the second orbit. So, first excited means the electron is in the second orbit. Third excited state means electron is in the fourth orbit, and so on. So, that is true. Now, coming to the next option given here. Energy of hydrogen atom in ground state is same as that of lithium in the second excited state. Lithium ion, it is Z is equal to 3. Second excited state means N is equal to 3. Again, Z square by N square is 1. So, its energy is also minus 13.6. So, the energy of hydrogen atom in ground state is same as that of lithium in its second excited state. That is also true. Energy of hydrogen atom in ground state is same as helium in ground state is wrong. So, A and B are wrong, C is fault. Okay, so let me check the correct option for that. See here. Next, energy of helium ion in first excited state is same as that of lithium in ground state. That is also wrong. So, only A and B are true. Choose the correct answer from the options given below. So, A and B are correct. Okay. So, second option is correct for that. Now, let us go to this question number 41. Look here. Question number 41. Moment of inertia of a rod of mass m, length L, about an axis passing through its center, normal to its length. About this axis, moment of inertia is L. We know it is mL square by 12. Moment of inertia of a thin rod about an axis passing through the center, perpendicular to its length is mL square by 12. Now, the rod is cut into two equal parts, and these parts are joined symmetrically to form a cross shape. Okay, passing through the center, perpendicular to the plane. So, it is cut into two pieces and both of them are joined together such that the combination forms a cross. Then what is the moment of inertia of the system about an axis passing through the center and perpendicular to the plane? Right? Now, look here. Moment of inertia of this about the central axis. Mass is halved. Length is halved. mL square by 12. So, this is mL square by 12 into 1 by 4. Similarly, moment of inertia of the other piece also becomes mL square by 12 into 1 by 4. The combination has the net moment of inertia mL square by 12 into 1 by 4 plus mL square by 12 into 1 by 4, that is equal to mL square by 12 into 1 by 4 plus 1 by 4 is half. This is given as alpha here. So, answer for that is alpha by 2. So, moment of inertia of this rod about the central axis is mL square by 12. It is cut into two equal pieces. The two pieces are arranged in the form of a cross. So, moment of inertia of that cross about an axis passing through the origin perpendicular to the plane is alpha by 2. Okay, that is question number 41.